Okay, to initialize the robot, we need to first turn on the motor power supply, which is found here, and then the other switch found on the other side here is the power supply for the PC-104. And when we turn on the PC-104, we'd like to make sure all the joints are set to their 0 position. So we have an initial condition for the encoders. So what we can do is extend the arm such that it lines up, and the arm is at 0 degrees, and the link 2 is also at 0 degrees. And then at that point, I'm going to switch on the PC-104. As soon as that switch is put on, the motor or the encoder counter card specifies that location as 0. And so now the bot is completely initialized at 0 position. And then I can flip on the motor controller right here. And the motor controller and the PC-104 power supply are completely independent, so they can, either of them can be on or off at any point in time without any repercussions. And so let's say my robot was set here and the PC-104 was on, or I had already done a test and this was my final condition of the robot. I would want to then reset the encoders to 0 position, and without restarting the PC-104 or anything, we can, while leaving the PC-104 on, we can then do another test by then again setting the robot to 0 position, and then by pushing a button found right in here on the on the encoder counter card, which will then reset all the joint angles. So all we have to do is just put everything back to 0 again, and then just push that button, and then everything will be set to 0 again. And there's no need to restart the PC-104. Okay, so now I'm going to go and show you the Simulink model. Can you get the whole screen in there? Just this. Okay. This is the first screen when you start up the Simulink model. We have a block here which is the end effector trajectory block, and that specifies the trajectory as a function of time for the end effector. And then we have the base trajectory block here, which specifies the base trajectory as a function of time. And if we can actually go back to the robot for a moment, the end effector trajectory will be this point here as it travels with time. So if we want to track a straight line, then this will be the point which follows that straight line. But the base trajectory is specified by the center wheel axle location right here. So it's a line along the wheel axle and on the center of the robot. So this will be the tracking point for the base. Now keep in mind that the center of mass is a different location. In this case, for the current robot setup, the center of mass of the base is at 0.116 meters ahead of the wheel axle, and that's somewhere around here. And so you'll need to take that into account when setting up your initial conditions, because the joints, the joint coordinates that locate the robot, part of that is the center of mass of the base. And so I have made note of that in the Simulink model. And so now, let's just set up the end effector trajectory. So I'll double click this block, and what this is just a series of different choices of code that I've made. Choice 1 here is for a straight line. If I scroll down, choice 2 is for a sinusoid. Choice 3 is if you want to track a stationary point on the end effector. And then choice 4 is a square wave. So what we're going to do is select, we'll try a sinusoid this time for an example. And then you can set up the amplitude, the natural frequency, the frequency of the sinusoid, and then the offset in the x direction and the offset in the y direction. So those are all set up ahead of time. And then these are the only things that you have to change. And then for base trajectory, the same thing, the same 4 choices exist. And so I'm going to pick choice 1 here, which is going to be a straight line. And then I just have an option of the y offset. I'm just going to have it follow the y equals 0, or basically the x-axis. And I guess one other note that I forgot to mention before was, you can set the choice here, and then this scale right here selects the forward velocity with time. So I have scale equals to 30. So if we come down here and we look, the position here, this is the x position as a function of time, and it's simply time divided by scale. So right now that forward velocity is going to be 1/30th of a meter per second. And so we can change the velocity simply just by adjusting the scale term here. And so right now I have them both set at 30. Okay, so those are set up. Another thing I have to set up is inside the get joint states subroutine here, I have to set up the initial conditions of the robot. And the only thing you have to set in here is the 3 integrators, which specify the initial condition of the base. And so for the initial condition of the x position of the center of mass, I go in here, and remember what I said, the initial condition, if the tracking point of the base is at 0 initially, then the center of mass must be located 0.116 meters ahead of that. So that's why I have that set here. And then for the y position initial condition, I have set to 0. And for the phi initial condition, I also have set to 0 in this case, because we want the base to track a straight line along the x-axis. Okay, so now we're done setting up the initial conditions. And I guess before I go to actually run the experiment, I want to show one more thing here, which is a calibration of the torques of the motors. On this side here, we can actually have this switch here, which is labeled calibrate. We can switch the switch. And what the switch will do is it will pull 0 input from a constant block of 0, and then what that does is and then you can go ahead and run the whole model and nothing will happen as an output, except only 0 will be input to the torques on all the motors. And then if a motor starts to move, you can go to inside the output torque subroutine. So inside the output torque subroutine, we then have this constant block over here, which is called calibration constants. And by clicking on that, then we can just play with the constant values of each motor until the robot doesn't move. And then we know we have 0 torque going to the robot. And so right now I have it set it up as 0, 0, negative 10, and 10. And that seemed to be a pretty good 0 calibration. And so that calibrates the robot. And so right now I'm going to switch the calibrate switch back so we can run the experiment. And now everything is set up correctly. And so what I'm going to do now is just hit Control B to build it. And while this is building, I'm going to go set the